Alright, hello, hello. Yeah, so very clearly I am 13 minutes late, so yeah, that's my bad. I was out and about. Hopefully y'all are still doing well, even if in my absence. Let me just check pings, okay. Alright. So, the big thing is I did a little bit of thinking last night about what the best way to implement Mentorage was. What's good, John? I realized there's a couple of other things I need to add to make it kind of bearable. So, the big one is just def use chains. So that is what I will also be adding today. Before any of that, I guess I need to do leetcode. So, yeah, employment time. Back to hunting for employment. Vowels game in a string. Okay. So they're playing a game. Alice removes non-empty substring that contains an odd number of vowels. Okay, sure. Okay. How do I even approach this? So, the size would be like the current state of the game, right? So, is there like, oh, it's math, okay. Well, I guess it's just doomed then, but, let's see. So then, okay, I guess we need to count vowels then, maybe? Is that somewhere to start at least? I don't really know what to do at all. Interesting. Programming language tier list. Let's put Rust and C++ at the top. Actually, no, C++ does not deserve to be at the top. Let's put Rust and C at the top. C++ a tier down. Python one more down because people use it for a lot. And then let's put JavaScript and TypeScript at the bottom. I think that's probably a good place to start. Also, I should turn off the AC. 1 second. Ah, there's my remote. I got it. Sorry, I'm really discombobulated right now. Okay. So I guess we can just count vowels, right? Yeah, I think that's the only thing that matters, so. So who removes how many vowels? Alice removes an odd number of vowels. And then Alice always goes first, okay. So let's just count vowels first. We're just gonna do some gross stuff here. Yeah, don't look too closely at this. Okay, so now we've counted vowels. And then turn what's good, Kane? Welcome back to the stream. So Alice starts first. Can this be compared? I feel like array is also like slow because you have to create it. I feel like this compare would be faster. Oh, wait, this is gross. Wait, I don't, wait, I'm like lost now. I forgot we can delete 0 vowels. So we need to see if we can give Bob a string with just 1, is what I'm getting. Is this just like, is this literally just like, does it have an odd number? Right? Yes, because Alice always goes first. So if it starts with an odd number, then Alice can just nuke it all. So then, and if it's even, then, oh, wait. Wait, so is this just like, wait. Is this like really, is this really silly, or am I just like missing something? Is this just... Right? Right? Surely it's not this silly. There's no way. There's no way. There's no way. Okay. So then here we want return true. So if it has a vowel at all, okay. And then otherwise we can return false. Right? Is this it? Yeah, okay, sure. So what is this? Oh, this is the really cursed bit comparison version. Or the not even the really cursed one that I saw on Stack Overflow that I don't understand. Oh yeah, I can get rid of that. But surely dead code elimination also gets rid of that. I'm sure this will not make this faster. Yeah. Yeah, that is quite crazy. Is there a faster way? Oh, we can use ranges. I've never used ranges before. That's really cool. That's really funny. Okay. Anyways. So that's that done. Yeah. Great. Wonderful problem. Okay. So, compiler proper here. So, last time we were trying to figure out how in the world we were supposed to implement mem2reg, which is pretty much taking all the stack variables we've made and then trying to turn them into SSA variables. And the problem I was running into is that there wasn't really any written way to do this, I guess. Because all of the literature is about just like turning, whatchamacallit? Most of the literature is about like taking just normal non-SSA variables and then turning them into SSA. But not much of it really talks about just like, I guess like none of it's like specific to stack variables, which I'm not smart enough to figure out on my own. So I will confess, I did consult a little bit of ChatGPT, for better or for worse, but it gave me some ideas. So x equals 1 or 2. Oh, I see. Yeah, that makes sense. And then presumably there's just like some masking stuff occurring? Question mark? Yeah. So we got some progress on this, but the big thing we need to add still is def use chains. So we want to keep track of which variables, I guess, like given a value, where it is used after it's been defined. So that's not that hard to do. We just need to like do a little bit more scaffolding, and then we need to build it properly. Yeah. So I think the easiest way to do this would just be to track it in the value class. And we can just track uses, I think. And then I think the values will then intrinsically point back to definition, or we could probably add that somewhere. Yeah. Yeah. We can just keep track of uses for now, because that's the only info we need, I think. So we want a vector of, what do we want to keep track of? Instructions? Yeah, we would want instructions. Yeah. What's wrong with this? We don't have instruction in here. Okay, we're gonna forward declare this. What? Oh, bruh. What's good, Niraj? So we need to include vector. Yeah. Okay. So what this will let us do is this will make renaming easier when we get to that point, because I guess I should walk back through what I was thinking about here. So the allocate stuff, so we have like 3 cases here. We're like iterating across all the instructions, and then we have 3 sort of instructions that we care about here. The first one is an allocate, which is sort of, we can think of this as like a variable initialization for now. In the future, I'll have some idea of how to manage these allocates, and yeah, the idea is like, if it's in the entry basic block, then we will treat that as a variable that we need to turn into registers. So we will process that later. For now, every allocate is kind of just like implicitly deleted, I guess. But we will figure that logic out in the future. The second type of instruction we have is a load, which represents a variable read. And then the third we have is a store, which we can think of as a variable write. And then we want to do different things on those. So the read, we pretty much just want to replace with the most recent definition of it. Wait. Yeah, I think so. And then the store is a write, so we want to, I guess, update the most recent definition. Can you theoretically modify std for your needs? And is it even useful if it's possible? Honestly, I don't really think I would get too much value out of it. I haven't run into an instance where like I need to like literally change how it works. It would make like a mess out of compilation though, and it'd just be easier to like make a wrapper or something, I think. You can add custom formatter to std format. For debug printing, I see. Yeah, I guess I could, but also like, eh. I don't think that's like too big of a deal. Okay, so we have uses. We want to be able to add to it. We want to be able to get it, and we want to be able to remove a use, I guess. Okay. Or we could even just like expose uses, I guess. So we want to return the vector by reference. Yeah, I haven't really looked too much into the differences between versions. That's something I really should though. Most people use their own logging frameworks. That would make sense. Yeah, I feel like most of the more recent C++ features just feel like them trying to, I guess, I don't know. It just feels like taking things that people have written libraries for and just making them part of the standard library. I don't really know how I feel about that though. Favorite assembly instruction set? I don't really have an opinion, to be honest. I haven't really worked with more than just the x86-64 that I'm trying to target here. I guess I've written some ARM at one point. I don't remember which one it was. That was like kind of a fun class though. Okay, so we want this here. This is value. Yeah. Yeah. Okay. Nice. So now we can get uses, and then the other thing we need to do to implement this properly is we need to update. We need to update the MIR generation, which shouldn't be that bad. We just need to like account for a couple of things here and there. So we can just walk through this slowly. Just every time we use something, we should update get uses for the thing with the instruction. And then the value is also the instruction, so that implicitly, I guess, defines backwards. Okay, so declaration, we don't have a use. Assign value, we might have a use. Actually, I think we have all of our uses are in here, right? Might all be in here. Instruction load. Yeah, this is the only place we have uses actually, I think. So yeah, we can just add it here, I think, and we would be good to go, to be honest. Okay, so we have that, and then we want to add uses somewhere here. So we want, we can pull out the thing in here, actually. Auto value equals, I guess, variable value. We don't have variables. We want a get value, and then we want to change this to value, I think. And then, yeah. And then what we need to do is we need to, yeah, would it be easier after the move? It wouldn't matter. So we can just do it here. So we have the putter, and then we can value dot get uses, and then we can add this instruction. Why doesn't this work? Do you think some offensive security knowledge is good for the level? Yeah, I think I think that's kind of like mandatory just with like systems, at least. Like in our systems course, we spent like a week just talking about like just like some basic low level security things. So things like buffer overflows and like I forgot what it was called. It was like return oriented programming or something like that. Return object programming, whatever it was. But yeah, we had like a whole lab that was dedicated to that as well, and it was pretty fun. So we want get uses. What type is this? This is a vector of instruction putter. So we want to. We can just do this, right? Okay. Yeah, I was just tripping earlier, it appears. Okay. So then this should keep track of all of the uses, which will make this way easier. Yeah, so then if we rename a value, right? Wait. Or do I have this the other way around? And then what does get value do again? Or what is value mappings again? It maps to allocate, okay. So then, wait. Yeah, so then this tracks the allocate's usage, right? Yeah. Is there any other place we need to do this? Maybe just anywhere there's value mappings? And 1, 2, 3, 4, 5 places. Okay. There's 5 places we look at value mappings. Okay, so that one. This one's the initialization. I guess we should track uses for the putter, huh? Right? Let's get a dominator. Should I be tracking uses for the putter? Maybe I should look at a sample program. Yeah. Yeah, so this store would have a use of that putter. Where's the loads? Yeah, we should be tracking for more things, I think. Alright. Okay, so this doesn't have any uses we need to worry about. This one we need to worry about the putter use, I think. Alright. Yeah, that does technically use it, I think. So we would need to worry about that in the store. Maybe I could just do this in the constructors instead, and this would make this way less miserable, I think. Yeah, maybe I should do that. And then we can just dynamic cast if it doesn't dynamic cast to a literal, then we can update uses. I think that might be the simplest way to go about this. Yeah. All right. Okay, let's undo all of this stuff here. And we can, I think we just change it in the constructors. What did I change? Okay. And where am I? Okay. Okay. So then we would just change the constructors then, which would be less messy. So, okay. So we put this in here, and then so we would need to add to left and right. So left dot get uses, this be arrow. So this is used in this instruction, so this. So then do I just like, oh yeah, this is a footer. Okay, nice. So we can do that, and then we can just write. And then we can do this in all the constructors, I think, and we should be fine. I'm also in college studying C language. Cool. Welcome to low-level programming, where everything is dangerous but really, really fast. So the call has a use, which is callee, I think, right? No, it's a function. No, so it doesn't have uses, I guess. Okay. So then the alloc also does not have uses, which makes sense. Load does have a use, adds a putter use. So this will be putter. Yeah. The load also has a value and a putter, right? Or no, the store. Yeah, because there's a value that we would want to store into it and the putter that we're storing into. So we want putter and then we want value, I think. Is MIR the extension? That is, I'm kind of just like making up extensions for all of the intermediate representations. At the end, it's just gonna be like an object file, hopefully, or I guess a .s, so human readable assembly. But for now, I'm just giving like AST gets AST, HR gets HR, MIR gets MIR. It's like, it's a little bit like silly, but that's kind of how it is. I think that's it. Oh, the return has a use. Okay. So then that would go into here. Yeah, okay. So I think that should be fine. Yeah, I think that should be fine for constructing it right now. I could maybe make like a print uses pass, but like, I'm just gonna trust that this is correct, which is definitely not the right thing to do. But what could possibly go wrong? So, anyways, Does instruction store need to return? No, because that's a constructor. So it should I don't think it would need to return if it's a constructor at least, or it'd be like implicit. Yeah, all good. It happens. It is technically a function, but yeah. Okay. So back to mem to reg. Let me actually just open this here. Okay. So this sucks. This really sucks. So the load would replace uses. And then the store, we would just update the thing, I guess? Yeah, this is... The comments I have here are like very much the book, I guess. So we have... so they don't necessarily make sense in this instance. That's all like theory. So the load wants to... Yeah, the load is the value from the putter. So we want to update all uses with and then I guess I could just delete the load. Unique putter. So does vector erase shift everything over? It doesn't, right? Yeah, it looks like it does. Yeah, okay. Yeah, okay. Alright. So we want to update uses with value at curval. And then we want to, I guess, delete the load. Yeah, because a load represents a use, so we want to just update all uses with the thing. And then the store we would presumably just update the value at curval with the but then how do we like account for fees and stuff? The AI response to our trash for writing code, it doesn't know the correct header files and return values for many things. Yeah, that roughly makes sense. You have to give it, you kind of have to like spoon feed it context. It's like having like, it's like having that intern who like claims to know TypeScript and then like you like review their code and then like they've just casted everything to any and you're like, bruh. That's kind of what asking AI to do things for you is like. And like they might be like smart and all, but like the code they generate is like terrible. And I say this in full confidence as a former intern. Like interns cannot write code. And then I guess delete store. But then we also have to like remove it from all of the places it's used, right? the store's not used anywhere, so we don't have to worry about that. Oh, I guess this should be fine though, right? Surely. Are you doing fee SSA? That is the plan, but I don't have control flow yet, so I don't have fees yet. That's the whole reason I've been like neglecting to mention them up to this point. So, yeah. I need to figure out how to account for those still though. Yeah, this seems wrong, because if there's a point where we would need to like overwrite with a fee, that seems like it wouldn't work. This sucks. This really sucks. Okay, well, yeah, I guess we will figure that out. I was gonna look something up, but I forgot what I was gonna look up. I think this is a good place to start though. I feel like there's like something really big I'm missing. Let me just draw out the scenario that I'm like thinking of that's like throwing me for a loop. So we have like this block here, which is like I equals 0. Or like I equals 0. Branch at like t greater than 3 as an example. Or I guess CMP. And we have a branch here. This one sets I to 1, I guess. And then this one just like, I guess does whatever. And then these return here, and then like return I. So we need a fee here, right? But this is a use, right? This would constitute a use. Wait, no it wouldn't. No. Cause that would have a load as well. Plug the Discord? Yeah, good cons. Yeah, join the Discord if you haven't yet. That's the best place to get to know me off stream and also find out when I go live. Like for instance, this stream started 15 minutes late and I made holy crap, I can't speak. I made an announcement there saying that I was going to be late. So that's the best place to find that out. And also you get to chat with me outside of hours and get a little bit more behind the scenes sort of reading from me. Yeah. It's also a great community and it's becoming more and more active. So you should join the Discord if you haven't. Anyways, thank you for listening to my presentation. I stayed up overnight at the library to create that one. Okay. Yeah, so let's look at the IR again, because I think this scenario that I'm thinking of doesn't make sense because the use is necessarily bounded by a load. Or like each use is a load, so we don't really delete like duplicates at this point yet. MIR, no, it's not here. Where am I looking? It's in test. Yeah, so as an example here, if we go to say this load here, if we look up %2, or I guess this load goes into register %4. Yeah, and this is just used once. Yeah. So I don't think that would be that much of a problem. And then it would be the same for all of these other loads as well. Yeah. So these two. And these are only used in here. And like this code is like really, really gross and really, really inefficient, but like that's what we're working on solving right now. So yeah, it'll clean up. It should clean up. I think I think I've like at least sufficiently convinced myself mentally that this will be enough. So we can kind of do this for now. Let's start here. So if it's an allocate, then check if lowerable. We don't even need to iterate through this then, actually. We could probably just go to all of its uses. It would only be used in like loads, right? So yeah. Yeah, it would only be in loads, yeah. Yeah, that might actually work. Yeah. Yeah, wait, this is big brain. Yeah. Yeah, okay. So we can just... So then we can even just get rid of most of this, right? So its only uses would be in allocates and stores. But then that'd be like annoying, huh? Yeah, because store order does not necessarily equal execution order. Yeah, okay. Then how do we deal with fees on top of this? I'll just do it this lazy way for now. So we would want this to be indexed actually. Oh, but then we'd be like deleting things. This sucks. This really sucks. Okay. So then I equals 0, and then end equals instructions, dot size. Let's actually make this cur, so we don't have like an overlap with I. No, we can't do that. Index. Yeah, we can just do this, I guess. And then, this is so hacky, I really don't like this. Okay. So we want to steal this stuff. And then Yeah. So if it's allocate, then can we just remove this from the can we just remove this allocate from the list, I guess? And then we'd have to like fuck with the index as well. Yeah, we'd have to subtract one from the index and the end. Which is like so gross, but what can you do? Yeah. So if this is an allocate, then we can cur get instruct. Instructions equals cur get instructions. So we can save a little bit of this mess. Do that, and then this can be instructions dot. What's the remove again? Let's see here. Yeah, there we go. Erase. Yeah, okay. So we want to erase end plus 1. No erase? What? Oh, begin plus whatever. I see. So we want instructions dot begin plus end. I don't like this code already. No, this would be auto I equals instructions at end. Yeah. And then that solves that. Okay, so this gets this dynamic casts it. If this isn't allocated, then we get rid of this instruction from the list, and then what if move out of vector? What happens if I do this? Does that erase? Yeah, okay. So we would want to move it. Are you actively applying for jobs right now? Or are you first refining your skills? I'm doing both simultaneously. Okay, this is this is gonna be a little bit of a mess, but we'll see what happens. Okay, so we want to update the thing then, I think. Yeah, because I think if we just erase it, it's gonna drop out of scope, so it's just gonna disappear, which would not be ideal. So we would want... crikey. Right, do I have curval? I should have it, right? Yeah, I do. So we'd want we're gonna do a little bit of slop here. So you can do that. And then let's actually move this up here. And then we can go down here again. And then we can move this into there. Stood move. No, this doesn't make sense. I try to use cling, but I guess G++ is default here, so I might be using that by accident sometimes. How do I manage this properly? I'm gonna try and do this without this, I guess. Let's look up unique footer. Actually, let's ask ChatGPT. Yeah, okay. Oh yeah, I forgot about that. Yeah, okay. Okay, so we can't actually make that change to this, which is probably a good thing. RAII stands for, I think, resource acquisition is initialization. Let me double check. Yeah. So I think the Wikipedia page is probably sufficient in explaining what it is. It has to do with managing, or I guess like making manual memory management a little bit less miserable. I don't really have a clear picture of what it is, so I don't think I can really give a good explanation though. It's a good chance for me to learn about it, actually. Yeah, okay. Yeah, I think this is probably the easiest way to think about it from what I'm getting here. Just like basically the parent class manages the or I guess the parent class is responsible for the memory within it. You can implement a defer. Yeah, I guess I could, but let's just defer. Yeah, I feel like it would just be less miserable if I just like stuck it on a vector somewhere. Like if I just take the alloc, stick it on a vector, and then like delete it. take care, Niraj. Passing a lambda that runs in the destructor. Interesting. I didn't know that. That's pretty cool, actually. Okay. So you want check if in entry block, and then we could even just do like a do while with a flag, which is really ugly, but so it goes. Okay, so we would need to, if I wanted to keep it, would I need to move first and then call delete? Okay, not delete. So we move and then we erase it. Okay. Yeah, so we want the erase there, and then we want oh Jesus, this code is so ugly. I really hate this. Let's separate that out just so it's readable. And then we want vector of unique putter of allocate, and this will be too lower, I guess. What is the term? Promote? Promote. Yeah, because we're promoting to register. Okay. So we can go down here, and then we want to insert this here. We want to move instructions dot at, yes, instructions. We can just bracket operator here, I think. Okay, we can even, wait, no, what am I doing? What type is this? Unique putter of instruction, yeah. Yeah, okay, so we can just be lazy like that and call that a day. Yeah. We can. It's probably the reasonable way to do this, right? You can set it cast to, oh god. Oh no. Unique putter of instruction. Okay. Oh no. This train car is really going a little bit nuts. Oh no, we can't do that. Damn it. Okay, so we do just have to do it like that, which is really ugly. But yeah, if anyone knows of a better way to do that, please let me know. I really don't like how that looks. Yeah, okay, so we've moved that. Okay, I think this is probably the fastest way to deal with the move, and then we can just erase it. Okay, so this handles the allocate. And then maybe I'll just make this a do while, and then, like I said, a flag, and that'll help me figure out the entry block stuff. Okay, so now, so this handles the allocate pile, and then, oh god. So now we have the loads. And then, so if it is a load, we want to update all uses. Maybe I do store first, because that sequentially makes more sense to me. Right? Yeah. Yeah, we can do that, and then I might actually need to put comments in this code. I've been like trying to avoid comments as much as possible because they don't usually end up changing with the code, which makes a mess, but low key, I don't think I'm gonna understand this if I don't comment this very thoroughly, so we're gonna have to throw in a couple comments for better or for worse. Okay. So let's worry about this first. We can, if it's a store, then we want to yeah, so we want to update the value at curval. It's curval at store.getPutter. That's the allocate. Yeah, that's the allocate putter. So that we will have to set to store get val, I guess. And then we have to do this really gross erase again. So we would want to do that, and then end minus minus. End minus minus, and then end minus minus. And then let's just stick a continue there. Yeah, so we can do that. Let's paste that there. I'm sure there's a cleaner way to do this. Yeah, we can just do that, and then okay, and then down here. Oh god. Okay, so then for other use in so we want load dot get uses. So for each use we want to there's not a good way to do this. We might just need to like pull a visitor here. Yeah, I think that's the best way to do this. Like an example of where this is important is like if we have, say, a binary op, and that's one of the uses. We don't necessarily know which operand uses it. So we need to figure that out. I also recognize that in an instance where both operands are a use, this will be double inserted into the vector. or it'll be double inserted into uses. Okay, well, let's get the easy part out of the way first. Yeah. I can do that, I guess. What do we do here? What do we do from here? What is the best way to do this? Okay, let's write a visitor, and then yeah, let's write a visitor, and then we just go through all of the possible values in it where it could possibly be used. And then if it is the thing, we just replace the thing. Yeah. So that means I need to make a visitor. I don't understand anything, but I hope you find that compilable. Thank you. Hopefully I'm able to explain some things. So if you're curious about anything, please let me know in chat, and I will do my best to explain it. No guarantees that you'll understand, because I'm like also still trying to figure it out for myself. So I don't really know how to explain everything necessarily, but I will give it my best shot. Okay, so we need a visitor. God damn it. Okay. So let's go here. Let's steal that, because we need to make a visitor. Let's go to mem to reg. And then we want this. We want replace use visitor. Then this. Actually, we should make a macro. So let's record, delete virtual. Let's do that. What's wrong here? Oh. Yeah, and then that cleans itself up, so we have that recorded. And then we can run that on these. And then, there we go. Do that. Okay. Oh man, it's so a troll to not implement other things yet. I really should have like a more built out language set. And I can see why the amount of work I need to do will just increase exponentially. Okay, well. Yeah, so it goes. So it goes. Okay, so that's the header. And then we need to steal all of this and then store it at the bottom here. We want replace use visitor. I think you started with one of the hardest slot passes too. The funny thing is, I feel like you're probably not wrong, but I also don't think there's any other pass that really makes sense to start with otherwise. Unless I want to be like writing all of my optimizations for stack variables. That sounds even less fun, so for better or for worse, I think this is kind of inevitable. Okay, let's make another macro for this. So record, start 0. Let's insert replace use visitor, and then change that. So then let's norm, and then There we go. Yeah. So let's start here. Load can, some of these might just have to be no-ops. Also, I need to make a constructor here because we need to figure out what we're actually replacing. The difficulty in compilers makes it more rewarding when you figure it out? Yeah, exactly. I might have become addicted to that. That might be why I'm still doing this and not in any other area of CS, I suppose. Okay, so we want replace use visitor, and then this needs what does this take? The value. So it should be a val to replace, or yeah, I guess use to replace and then like replacee, I guess, replaceand. I feel like I'm really losing it here with these variable names. I like the way replaceand sounds. Replaceand. Operand versus operee? Is this a thing? Okay, so it's definitely not the replaceand. I don't know. To replace new val, I guess. New value. Let's just, yeah, we could just do old value, new value. What am I doing? This is like the least miserable way to. Yeah, okay. Yeah, whoops. Okay. So we want private. This has more value, star, old value, and then new value. Okay. Okay. Who knew this could be so fun? Oh, whoops. Okay. Oh, god damn it. Okay. There we go. What else do we need to do? I think I could just make like a helper try replace, and it would not be that difficult, to be honest, to do from there. So we can just like void try replace. Value star val to replace. Yeah. And then these should just be putters, so it should be fine. Also, yeah, I have boba. That's what I've been sipping on the whole time, if you were curious. Okay. So let's also just implement try replace real quick, and then we can just keep calling that. Yeah, this is like really silly, but sure. I think this will save a lot of random writing. Oh wait, no, we can't do this. No, we can't do this. No, we can't try replace. No. Because we can't modify it. Damn it. Okay. I feel so whimsical right now, but I am also just like really struggling. Okay, binary op if I get left equals old value, then we need to write mutators. God damn it. Okay, another detour here. I should probably push what I have so far for the value changes. Yeah, so yeah, that is about right. Yeah, okay. So you can add all those. What do we call this? This is track def use chains in MIR. Get add p? Is that a thing? Oh. Oh yeah, that exists. Yeah, I guess I could do that, but I'm quite lazy. Maybe I'll do that in the future. There's been like some commits where it's just like slush, and I've wanted to separate it, but then I forgot, so yeah. Thanks for letting me know. I'll definitely use that in the future. Okay, so yeah, we need mutators. That's what we need. Okay. Let's start with binary op. Yeah, what I initially wanted to do was I wanted to just make a new instruction instead of mutating in place, but that seems even worse than what we're doing here. So we will just make mutators. Let's do that. Yeah, and then this way we can just continuously copy paste. Should probably group them all, I guess. That might be easier for me to manage mentally. Let's see. Yeah, so that's all I need for binary up for now. Call doesn't need anything. Allocate doesn't need anything. Load needs a putter. But we don't need to change that. I think binary up might be the only use, huh? Oh wait, no, it might be in store. Yeah. Set value. Let's put that down there. And then Terminator, I think there's a chance. Oh yeah, we'd also need to check that, I just realized. Oh wait, no, that's already included in uses. I think we construct with it, so that should be fine. Yeah. So that would be in return. Yeah, there we go. Okay. All right. Let's steal those. So it goes under these getters. So we want left equals new val. We can even just nice. What's the next one? Yeah. Instruction store. You're a lot more disappointed about sliders and getters? Yeah. This is more just that I made a bad design choice. I really should have just used structs in hindsight, but I also feel like this sort of sets a ceiling on the number of mistakes I can make. If I were to restart though, I would definitely just use structs. This proper object-oriented encapsulation is really not worth it. This was very, very silly. Instruction store, we need set value, do that, and then last one is in return. There we go, right? Oh, come on. Seriously? That's the thing? Redefinition. Wait, so why isn't this a problem with the getter? Oh, wait, duh. Wait, I'm stupid. There we go. Okay, we figured it out. NT me. So then that should be fine. And now we can go back to where we were, which is pass. And then here, I set left. So this needs to be new value. Can make this right. Maybe I should have just made a macro for this, but you know, whatever. That would have been the disciplined thing to do, arguably. So the call doesn't have anything, the allocate doesn't have anything, the load shouldn't have anything. Yeah, it shouldn't have anything. Right? No, the load is what we're processing, so it shouldn't have anything until we have like putter values, but ah, Christ, okay. You know what, let's be future thinking. Let's be future thinking here and let's extend it to include potential putter values. Okay. So there's only two values in here. Okay, there's a value there that we count for. Okay, I lied. Let's not be future thinking. Let's not be future thinking. I don't want to worry about this right now. But this does help figure out where we need things. We need it in store as well. We can do that, and then the last one is in return. And then, but here, this is not I, this is T. There we go. So then 39, we can go back up here. We need to make the visitor. I forgot how I made visitors before. Yeah. So we do that. So this is the visitor, and then this is... This takes in... load, and then load dot get putter. Right, no. We want curve val at load dot get putter arrow. Okay. All right, that seems correct at a glance. Yeah. So we want to replace all uses of load. Yeah, okay. Yeah, perfect, perfect. Okay. So then we want to use dot accept visitor. Oh. Like that, right? Oh, yeah, okay. Am I dumb? Did I forget to do the thing? Bruh. Public. There we go. Oh, Jesus Christ, this sucks. This really sucks. Yeah, okay. Cool. Do we want to give this? Do you want to give this a try? I think we've done it correctly, but I'm really scared that it's not gonna work. So let's try building first, just to make sure there's nothing obvious that I missed. Okay, well, gtest builds. Okay. Let's just make tests real quick, just to. Okay. Oh boy. Oh, how am I even gonna test passes? Or, yeah, how do I even test passes? It's gonna be really gross. Okay. Let's throw... Okay, let's throw this into here. Okay. So then we need to actually add the passes now. Oh lord, okay. So let's make a pass manager. We need to import pass manager. We need to include a lot of things. Middle, and actually we could get rid of these now, even technically. Pass, and then pass manager. And then we also need to include mem2reg for a fact. Yeah, okay. So then, oh geez. So we want we have a constructor, right? I hope we have a constructor. Oh, we have a default constructor. That's fine. Okay. So we want pm.addPass. Mem2reg. Right? Is this good? Oh wait, no. Okay, we need to make it. Mem2reg equals stood make unique mem2reg. What does this take? It looks like it doesn't take anything, which is nice. And then pm.addPass mem2reg. We need to make a unique footer to transform pass. Oh, whoops. Why doesn't it let me do that? Because this is a transform pass. Oh, wait. I forgot to do the thing again. Right. Huh? Can we just do this? Okay, let me look this up. A unique footer. What is polymorphism? Oh, I can just do that. Right? So this would be what? Transform pass? Okay, so it does work. Nice. Okay, so now we add the pass and then run passes, I guess, on MIR. And now let's see what happens. Please, please build. Okay, that's good. Make test. Okay, that still works. So then let's just go to our, let's go back to our scuffed test repo. Oh no, oh no, that's not what I want. Oh no. Okay, so just to confirm that it is just that. Let's go back. Oh no. Okay. Alright. So let's add this for now. Okay. So it has to be in here, obviously. And then so let's include std.io or what was it? IO stream. Say it ain't so. Let's make it print some screaming text. Because I want to scream. And this is not unexpected, to be fair, but wait, what? Yeah, okay. Okay. So let's undo all that. So it has to be in memdireg. Has to be in memdireg. Something is segfaulting in here. How do we even begin to test this? Let's put that there, I guess. Yeah. let's do this and then allocate and then screaming text. So I feel like I'm doing a little bit of insanity here. Let's do that in store and then that in load. Okay, let's give that a try. Let's see where we go from here. Okay. So where is it quitting? Okay, so this is test calls. So it's in here. GDB, I could, but I'm gonna save learning how to use it for another day. Okay, so maybe I should, like get rid of some of the screaming text. I don't think this is, okay, let's just make this a little bit more sane. Yeah, we can do this. Make. Okay. Let's see. So it handles this one. Yeah. Wait, there's an allocate here? Wait, what? Maybe I should... Let's do this. Let's do that. So now we can split by function. Okay, yeah. Yeah, that's a lot more readable. Okay. This one's like trivial, this one's trivial, so it's all in this one, which makes sense. I can compare with the code up here even. Yeah, let's just ink that. Let's comment that out so we can read this. Okay. So we have this allocate here. At this load. And then the store, and then we have the other load. Wait, so it's getting through it, right? What's segfaulting? Wait, what? That's the function, so we can just... Oh, Jesus. 1 second. Okay, so it gets through it, which means something is going wrong somewhere. What could possibly be going wrong? Something's going on in the print then, right? Surely. Yeah, okay. So let's clean all of this up for now. Yeah, okay. Let's clean that up. Okay, what do we even do here? Yeah, okay. Let's start with that. Okay, so so it is failing in there. Very much. So what's it supposed to be after this? Call, and then a call. Yeah, that should be, and then the return? Okay. What? Okay, so it is failing in here. So then we must be doing something wrong in the replacement for the terminator. Or with the return. But where? How? Who, what, where, when, how, why, what, how, why? What? Do I? Wait. Okay, so this means that it's not being processed then, right? So that implies something going wrong in the construction, maybe? Ah, wait. What? No, this is here. What? Yeah, so this has getters, or this has setters, rather. That's the load. Load, that's just the putter, so I don't care. This has a value. We shouldn't have stores anymore, so that shouldn't be a problem. Because we're literally processing the store, so that's fine. And then we should be calling it. What? Okay, yeah. So it is failing in that. So let's go back up here. Gotta love unemployment? Yeah, that's how it would be. What's going wrong here? Okay, let's try that. Wait, what? Oh, wait, okay. Yeah, so it is visiting it. So then... Yeah, okay, so it is updating. So what's happening to new value? Maybe it's like falling out of scope somewhere? Because this is the only store in this, so presumably that's getting nuked. So this is, so I don't think the issue's in here at least. The pointer should still be valid. What could be going wrong here? I'm gonna throw this in the ChatGPT. Let's see what it says. Anything wrong here? Yeah, we will handle that. So fees we don't care about yet. It's fine. Yeah, this ain't helpful. So what should this be turning into? we should be getting like something like this is deleted. This is deleted. And then, so this store should update it to okay, wait. Okay, this is still visible. Okay, good. So what should be happening? So this should make this exist on the thing. So this should map putter 0 to 1. Alright, wait, what? It's crashing when trying to print the return. Wait, what? Okay. Let's try and simplify this a little. I can tell you're probably busy understanding this. Got into this because it's trying a compiler for C and C++, but you can do this. You too, man. I believe you can as well. Let's just simplify this down. Actually, we can even get rid of this extra one for now. First equals 1. First equals 2. Turn first. Yeah, so then let's cast mem to reg. Oh wait, that prints. Wait. What? Wait, what? Wait, so that works, but then... Okay. Wait, so what's causing the issue? I guess this also implicitly handles, okay. I guess this does implicitly fold, which is really funny, but... So it like kind of works, but like not really? Oh wait, this is not. Okay, so that's breaking. There we go. Wait, so what if I do 1 plus 2 here? Okay, so that works. So A equals 1, B equals 2. Okay, that works perfectly fine as well. That even does a little bit of folding, so... Or a little bit of constant propagation, rather. So it's breaking on the call, is what I'm getting. Not on the return. So... Where is this failing then? Does the call take a value? The call itself is a value. It should be getting stored. So let's just do this call raw. Or just raw. I can't type. Wow. Wait, what? Wait, am I just constructing this wrong? Is that what's happening? Wait a second. Because that'd be so funny if that's what's going wrong. So that'd be in here. This would be under call assign. So the make unique is fine. And then wait, why am I making an allocate? Oh wait, no. Wait, no, this is right. So here's a putter. Store. Wait, what am I doing? Wait, no, what am I doing? No, I I put the call in here, not... Wait a second. Oh wait, no. It's called a get. Wait a second. Wait, that might actually be it. Wait. Holy shit. It was that. It was literally that. I actually had an error in my Oh my god, I'm so miffed actually. Okay, so now the regression tests are breaking, but that's fine because that was wrong then. Right? That should break. Yeah, okay. Right? Wait, no, that doesn't break because I don't test it because my tests are Okay, well, good news for me. I figured out what was going wrong. Bad news for me. My tests are god-awful. So... Yeah, because my tests don't have a call in them. Of course they don't. Okay. Alright. Alright, enough molding. The good news is I think I did this correctly pretty much on the first try. So... Yeah, yippee. Okay. Yeah, okay, sure. So let's get rid of that. Fix bug in MIR construction with call value. Yeah, I don't think I've felt this happy in a month, to be honest. Holy hell. Okay, this also means I need to write more tests, because holy hell, my test could not catch... My test cannot catch shit. What did I change here? Mutators for that. Okay. Wait. Okay, I do need to get rid of that print slush real quick. Okay. There we go. So let's rebuild this. That was so dumb. Okay. Yeah. Yeah, function name is correct. Or it's like the function name is fitting. And finally, oh wait, I should fix the comments in this real quick. Because I am not gonna remember how this works. So this will take store putter. So this, no, because we get rid of this store, right? Yeah, we'll just do this. So let's give this nice little comments because I'm going to forget how all this works. Visited would have to go down there probably. And then, okay, then we'd have to update visited here, right? Yeah. That, and then pre-order DFS pre-order traversal. Actually, no. Yeah, I can explain that down here because I'm going to forget. I don't need that even. I think that's pretty obvious. And then here we also want to set visited. And then visited is a set, so insert, yeah. So this, we only update fees, not visited. We want to I guess we'd want to update the fees regardless, huh? Update fees and rename in instructions. Okay, we want to, if promotable, we want to hold onto and delete. We can just steal from instructions. Yeah. Also, if you weren't here when I was explaining why I'm writing comments, even though I haven't been writing comments this whole time, I sure as hell am going to forget what I have done here. So, it will, just for my own sanity, I am going to write comments here. And I usually try to not write comments because, usually when the code changes, what ends up happening is the comments end up not changing. But I feel like here it's just so important that I think it justifies it. Store, we want to update current value. Maybe I need to like do a stack or something. For the, I don't know. Load. Use current value. All uses of the load with current value. Yeah, okay. I don't think... If we use it in another basic block, what's gonna happen? So we'd have a load somewhere. Oh, and then if a fee is inserted at the top of the block, then we can just get the value that it's mapped to from... Yeah, actually, yeah, that's fine. Yeah, okay. So then I'll just make a comment here, I think. Fee, we want to... previous basic block. And then I assume when I insert the fee, I will also make the relevant changes. Yeah, okay. Just do that. This seems reasonable enough at a glance. Right. Seems correct at a glance. Let's compare against the book algorithm. I'm kind of curious how it compares. Yeah. Let's just pull this up. Renaming. Okay, so for each variable use, so that would be loads. Interesting. We're supposed to... I guess this is kind of done incorrectly, but... Interesting. Okay. I guess we can't really... I guess like in this... Oh god, no. Okay. I think in the book, it makes sense to do the variable replacement on store, but we can't really do it here because we don't really know where the corresponding uses live, I guess. I could just be reasoning about this completely wrong though, so please correct me if I'm wrong. We probably handled the entry block stuff real quick. Let's make this a do while. And then let's do bool is entry equals true. Is this the do while? Work list.empty. Right, is that the correct one? Yellow bracket, okay. We don't even need a do while for this, to be honest. We can just set it at the end. Yeah. Okay. So I'll do this, and then if allocate and is entry. So then here we want to remake this. Okay. So then we want to go after this loop. And then now we set that to false. Okay. Can do it in this order as well. Yeah, okay. Maybe if it's possible to just skip this dynamic cast, I could probably rewrite this, but let's add memtreg again. Let's make, just to make sure it still runs properly. Yeah, okay, nice. Finish mem to reg. I'm really surprised they got it, actually. I can't lie. And then we want to throw this into compiler as well. or like clean this up a little bit. Yeah, actually this is probably fine. Right. Yeah, okay. Add passes to compiler. Alright. So I think that is a perfect spot to wrap up today. We got so much done. So yeah. Thank you all for sticking around, even if I started stream like 15 minutes late. Yeah, make sure you like the stream and sub to my channel. It really helps me out and gets my content pushed out to more people. While you're down there, you should join the Discord. That's the best place to chat with the rest of the community and to get pinged when I go live. And yeah, also connect with me on LinkedIn and add me on GitHub. So yeah, take care y'all. Take it easy. Thanks for sticking around.